So welcome to lecture number 6. Since last time we had a quiz, which by the way, I have not yet graded because I've been grading all my other stuff. I had 200 quizzes or so to grade. And because this one was the longest and wasn't due until Sunday night, I have not done it yet. But that being said, just a quick poll on how it was. Too easy, too hard, too obvious, too impossible. I mean, what was the general consensus with the difficulty level of the quiz? Just right, no surprises, right? I mean, the questions. So I don't think there was any question there that was. Yeah, I mean, listen, there might be one or two that were a little more complicated, but that's to be expected, I think. Suffering as usual. Well, welcome to my life.
Professor?
Huh?
There was like one question that was asking whether you can tell if it was like either right skewed or left skewed or symmetric. I actually reversed. It was asking whether like, oh, the testing was probably easy, the testing was hard.
Yes,
Yeah,
yes. Okay.
I don't know if we talked about it.
Well, let me share my screen first of all. So here's the quiz. And the question that you're asking about is
I think it's number 2.
2. Oh, okay, yeah. So the distribution of scores in a certain statistics test is strongly skewed to the right. So if I were to draw a strongly skewed to the left. If I were to draw a strongly skewed to the left distribution, it would look like this, correct? Right?
Yeah.
This is a strongly skewed. So we're talking about the grades on a test. So let's assume that the grades go from 0 to 100. Okay? So the question is, what does this suggest about the difficulty of the test? Well, not a lot of people scored low, but a lot of people scored high. So it was probably an easy test. Not really a statistics answer, it's a common sense answer. Does that make sense? Right, it makes sense, right?
Yes.
So are the tests going to be the same format or will it be on Launchpad? I lack common sense. No problem, John. I'll fix your attendance. But, yeah, so if you have no common sense, yeah, that the statistics sometimes can be tough if you have no common sense. Just true. But in general, I mean, notice that I made a graph. I made a picture, right? Because sometimes, sometimes it's hard to see what's going on, but you make a picture and everything becomes clear. So in my case, the first thing I did, I said, okay, what does it look like? It looks like this. Oh, it's testing. Low scores to high scores. Lots of high scores, not a lot of low scores. Probably easy. Right? Not really a statistics answer, more of a common sense answer. But did that make sense? Right? So, there might be a couple that were a little more challenging or, I can't have every question carbon copy of something that you've seen. It's not really a test then. That's just checking on your ability to memorize. So there's going to be, some ones that are different. So someone asked, are they going to be the same format or will it be on Launchpad? So I don't know about the final because the final is department-based. But certainly the tests that I write are going to be like this. So question number 9, someone says, could you do number 9? So let's load again and see, quiz 1, number 9. It says, about what percent of the data is in the box for the box plots? Well, that one we certainly did do. Right? We know that a box plot, whether it's symmetric or not symmetric, is split into 4 parts. 1, 2, 3, 4. And each part is roughly 25%. First 25%, next 25%, next 25%, next 25%. So the box is the inside 50%. And that is something that we certainly covered. I mean, I remember saying it. Do you guys remember hearing it? Because I remember saying it. But then again, I'm teaching 4 stat classes this semester. So sometimes I think I said something and I said it in a different class.
Professor,
Yeah.
when do you think the tests are going to be graded?
I usually do most of my grading over the weekends because I teach 8 classes and I take a class and take 2 classes actually. So I'm really, really busy during the week, which is why I usually just push off everything to the weekends. I didn't do it last weekend because it wasn't technically due till Sunday night. So I was waiting, and I think people still send it to me like early Monday morning, like after midnight. So it should be graded this coming weekend.
So if we email it to you, that's how you're supposed to submit it, right? If you emailed it to you.
Canvas, email. I had a number of people do Canvas and email. And then some people sent it to Canvas and all my emails just in case, because they didn't know which one it was. So I have lots and lots of emails. The 50% box plot was not in the PowerPoint. Well, let's see if that's correct. So let's go back over the PowerPoints quickly. Let's see if I can find it. Because if I can find it, then let's see. Hold on, let me do this quick.
I have a question. Did you go ahead and email us back when you received the quiz? Because I wasn't sure if you received my quiz or not, so
No.
I just wanted to check. Oh,
No.
all right.
No, nothing like that. If you sent it to me, I probably got it.
All right.
Yeah, I didn't respond. So hold on. I was checking if we ever specifically covered that. Just give me a second here. Okay. Oh, where are you? Okay. So I guess this might be the closest to answering that. So let me share my screen. All right, so we have the following, all right, we have the following box. It says, right, so first you arrange the observations in increasing order and locate the median M, right? So the median is the one right in the middle, correct? Yes, the median is right in the middle, right? Yes, no, maybe so? This is your part to say yes or no?
Yeah. Yes.
Right, the median is certainly right in the middle, correct? If the median is right in the middle, then the median certainly divides the data into the left 50% and the right 50%, right? All right, because it's right in the middle, half on this side, half on this side, correct?
Yeah.
Yes, and then if we take the first quartile, which is the median of the left, it should take that 50% and divide that into half and half, which is 25% and 25%. And Q3 on the right should divide that side of the half 25% and half 25%. And since the box plot, then, since the box plot, wherever it is, I don't even know if it's on this one, since the box plot has minimum Q1, Q2, Q3 maximum, this is the median. So to the left of it is 50%, which means 25%, 25%, 25%, 25%. So it's possible, the box, yeah, so it's possible that I didn't specifically mention that. To be honest, I just don't remember exactly word for word what I said. So it's possible that I didn't specifically mention that, but I certainly went over that PowerPoint. And from that PowerPoint, it would be possible to infer that. So again, I can't promise that I mention every last thing, that is out there, but that's why also we have the book, right? Launchpad has the ebook, and on the ebook, you can always read it and glean from it any additional information that that I might not mention. Does that make sense? I hope it makes sense. It made sense in my head, and that's really what counts. Okay, so anyways, so let's go back to chapter 3. So I'm loading up the chapter 3 PowerPoint. I'm gonna close the quiz down. Does anyone remember where we left off on chapter 3?
I think it was slide 17.
Slide 17. So we did 17 already, or we were about to do 17? Do you recall?
I think we're about to. I'm not sure though.
I think we finished. We went over slide 17 a bit, but I'm not sure if we finished exactly.
Okay. Well, then let's start it again, because it's never a bad idea to go over things anyways, right? So let's go over it again. Okay, so what does slide 17 say? Slide 17 is about the standard normal. So let's recap. Let's recap what we're doing here, right? We have a situation where you have a normal, correct? Right? Yes, no, maybe so?
Yes.
And the normal distribution looks like what? It looks like the shape on the bottom right of slide 17, is it not? Right?
It does.
Okay, so if you look at the slide, bottom right of slide 17, it looks like a normal. Now, every normal distribution has a mean, and every normal distribution is going to have a standard deviation, correct? But every one is going to be different. Every normal is going to have a different mean. Every one is going to have a different standard deviation, right? So what we want to do is we want to be able to compare different situations. We want to be able to say, okay, your mean and deviation is this. My mean and deviation is this. I would like to be able to compare. A great example that I saw recently was you took the SAT, your friend took the ACT, and you want to compare your answers, right? Who did better? But they're graded differently, right? An SAT is graded out of 1600, an ACT is graded out of what, 32? I don't even know offhand. They're graded differently. How do you compare them if they're on different scales? So the answer is that we standardize. We get everything based upon the same type of distribution, which is a standard normal. It's the one whose mean is 0 and whose deviation is 1. And if we can get them all onto the same one, then it's a lot easier to compare. All we can do then is say, okay, on this one, you got a 13 and I got a 14, so I did better. So how do we standardize? How do we get everyone onto the same one? So the answer is that we calculate what's called the z-score. Now, have we already talked about the z-score yet? I don't recall whether we mentioned that specifically. Have we talked about the z-scores?
Briefly.
Yes, you showed us how to use a graph.
I showed you how to use a graph. Okay. So in this case, what we're going to do is we're going to calculate the z-score. You take your data, x, you subtract the mean, mu, and you divide by the standard deviation, sigma. When you do that, you have this thing called the z-score. And the question is, what does the z-score represent? Well, look at that slide. Look at that normal distribution at the bottom of the page. Okay, what it represents is as follows. Okay, on this distribution, 0 is always going to be the mean without exception. 0 is always the mean of the standard normal distribution. And the standard deviation is always 1 without exception. So every one of them is exactly the same one. Your z-score tells you where you fall in relation to the standard to the mean. In this example on this slide, our z-score is 0.81, correct? What that means is that you scored precisely 0.81 deviations to the right of the mean. Your z-score tells you, that's exactly what it tells you, how many standard deviations you are from the mean. If it's positive, you're on the right. If it's negative, you're on the left. Does that make sense? So I don't need to know your actual mean, and I don't need to know your actual standard deviation. All that matters is I can tell you from your z-score how many deviations you are from the mean. And because we're both normal distributions, I can compare us because I'm this many deviations away from my mean, and you're this many deviations away from your mean, and therefore that's the answer. So the purpose of the standard normal distribution is to be able to compare more easily multiple distributions, first of all, and two, to make computation of values easier, as we're going to see. So let's go to the next slide. Okay.
Just
yeah,
to clarify.
Yes, yes.
Sorry. And so the z-score would essentially be the standard deviation compared to the standard normal.
No. Your z-score is how many standard deviations you are away from the mean.
So that it could be easily translated into the standard normal graph, correct?
Well, the standard normal graph tells us precisely your z-score.
Okay.
Okay, in other words,
That makes sense.
if my z-score is 1.3,
Yeah.
and that tells me on the standard normal distribution, I am 1.3 units to the right of zero, to the right of the mean.
That's exactly what I was thinking. Perfect.
Okay.
I have a question. Are there any units for z-score, or is it just the number?
So let's think about that. There are no units, because if you take your x and your mean in the numerator and you subtract them, let's say you're measuring something in feet. So 5 feet. The mean is 3 feet. The deviation is also measured in feet. So when you divide feet by feet, what do you end up with?
Feet.
No, feet divided by feet is what? Anything over itself is what?
1.
1. So the units cancel when the unit in the top and the unit in the bottom are the same.
Oh, gotcha. Thank you.
Right? So because they cancel, z-scores have no units, which is also important if you think about it, because if you want to compare different distributions and they have different units, how are you going to compare them? I mean, what's bigger, 10 feet or 3 seconds? The question makes no sense because the units don't compare, right? So the whole idea of z-scores is to be able to compare different distributions. The only way that can work is if we don't have units, right?
Okay, thank you.
Make sense?
Mm-hmm.
Okay.
Professor,
Yes.
I have a question for slide 17. How
Yeah.
did you get 0.7910?
Okay. Did I show you yet the table yet of z-scores? Have we done that in class?
So they just looked at the table. There's not really like
Right.
math.
But have I shown you how to use a table yet? Have we gone over that?
Yeah.
Yes.
Okay. Yeah. So this is a portion of a table right here. On the bottom left is a portion of the table. So they say if they want the proportion of the probability that z is less than 0.81, they just go to find 0.81 of the table, and they see that right there it's 0.7910. Straight up reading it off.
On the graph, it just means that the z-score, which is 0.81, it's 0.81 deviations from the mean.
It's 0.81 deviation from the mean, and the percentage of the area to the left of it is 79.10%. That's what the 0.7910 represents, that the proportion of area to the left versus the entire area is 79.10%. It's 0.7910. That's how much area is to the left compared to the whole thing. Does that make sense? Did I lose you? I'm hearing silence. Silence is the bane of a teacher's existence.
The mean is 0 in this case?
Well, when you standardize, you always create a situation where the mean is 0. That's the purpose. That's one of the advantages of standardizing, is that you create a situation where the mean is 0. And in that situation, the standard deviation is also 1. It comes along for the ride, which is really nice, okay? You can actually mathematically prove that. We're not going to, okay? So what you get when you standardize is you still have a normal curve, okay? You haven't lost the normality of the situation. But what you have now is that you can more easily compute the area to the left of your value because we have tables that can do it for us. Of course, nowadays, calculators and computers can do it even without you standardizing. But back in the day, we weren't able to do that. So back in the day, we had to convert to the standard normal, and we had these tables to look up. And I still have books. My father, I remember he's got books in his library, huge math books. of nothing but tables and formulas that is completely obsolete now because you can find everything online. So, you have to recognize that sometimes we can have these possibilities, and sometimes we teach both ways, even though there's more modern ways of doing things. Okay. So let's turn now to this question. I'm sorry.
Okay. I'm so sorry, everyone. But just to clarify everything.
Yeah.
So 0.81 is how many standard deviation is from the mean. And
Correct.
at 0.81, 0.79110 is the percentage of that portion.
Is the percentage of data points left of that value, to the left of it.
Left of 0.81.
Yes. So
Okay.
So whatever your original distribution is, SAT scores, ACT scores, whatever the case may be, if we asked you what percent of people did you score better than, if it turns out that your Z-score is 0.81, that means you scored better than 79.10% of the population. Because 0.81 in your tables corresponds to 79.10%. I'm getting silence again.
Okay, that makes sense.
Well, for you, but maybe not.
You put that into a calculator with no specific equation that we use, and that will tell you everything that's to the left.
We are not using equations here. We don't have the math for those equations. Your calculator just gives us the answer. And tables just give us the answer. We're not going to compute it. If you scored at a certain grade and it turns out that your Z-score is 0.81, what that means is that you scored better than 79.10% of the population. That is what that Z-score implies. It tells you not only where you fell on the normal curve, but it also tells you what percentage would fall to the left of you. Yes, Sydney, makes sense?
Yes, way better. Thank you.
Sure. Okay. So let's look, let's do some calculations. And I think the more calculations we do, it'll become a little clearer. So what we have on slide 18 is a normal distribution. It has the basic bell shape as expected. And it says what proportion of observations fell between negative 1.25 and 0.81. So what proportion fell between them? Now, do you guys have a calculator, a TI calculator, or something comparable? I'm going to show how to do it on this. And if you don't have one, there is probably, if you just do a quick Google search for a normal distribution calculator, you'll probably find some applet or some Java program or some whatever that will do the same thing. But I will demonstrate on the TI 1.84. Because that's what I have. Okay, but hopefully, you know what? Let me share. Let me do exactly what I just suggested. Hold on. Normal distribution calculator.
Your screen while you do.
Yeah. Well, first I'm going to find one. So hold on. Okay. So this is a beautiful one right here. I'm going to share my screen. Okay. So what we have here, is normal distribution. I typed it in pretty badly, and the computer recognized that my typing abilities is horrible and said, "Did you really mean normal distributions calculator?" And the answer is yes, I did mean normal distributions calculator. And the very first one, I'm going to click the normal distribution calculator online Statbook. I'm going to click it here. And the first thing you notice is that this particular website, when I put in my parameters, it gives me options. If it's above a point, it'll shade to the right of it. If it's below a point, it'll shade to the left of it. If it's between 2 points, it'll shade inside. And if it's outside those 2 points, it'll shade outside. So this is really a nice calculator, which I've never come across before. But our question on the slide is, find the proportion of observations between negative 1.25 and 0.81. So I'm going to go between negative 1.25 and 0.81. Mean 0, deviation 1. That makes it a standard normal distribution because that's exactly what a standard normal is, mean 0 and 1. And then I say recalculate, and it gives me 0.6854. And this answer here is a 0.6854, right? So the calculator just did it for me. How was that? Was that nice? Look at that. The first link I found was an amazing calculator. Left, right, between, outside. All you got to do is plug in the mean, the deviation, and your number or numbers, and boom, there you have the answer. Did that make sense? And again, not saying how they got it, right? This calculator is not telling us what they plugged in to make everything work. It just gave us the answer. Okay, can we use that during the test? Sure, tests are open book, open notes type things. So yes, you can use an online calculator to compute your normal distributions. Okay, we don't do them by hands. How do you do it on the TI? Well, that's another question. So let me do that quick. First thing you want to do is you want to turn it on. That's always a good idea. I'm going to spotlight here. Okay, so we're turning it on, and you'll see here in green, in blue, is DISTR, standing for distributions. It's in blue, so we got to go to blue mode. So we hit seconds, and then we hit that button, and all these things pop up. Okay, so we have distribution and draw. I don't really know what the draw is for, but we have the rest. Okay, so you see that? Everyone with me? So now if you go down, you're gonna wanna go down to normal CDF, the very second one, normal CDF. So go down to normal CDF. Okay, and if we click normal CDF, it'll give us this. And what we see here is lower, upper, mu, and sigma. So what do you think that means? Well, it's telling us from where to where, lower to upper, from where to where, with what mean and what standard deviation. So in our example, we're going from where to where. What's the lower? Someone tell me, what's the lower?
Negative 1.25.
Negative 1.25. And what's the upper?
0.81.
0.81. So put in lower and upper. And now that we have lower and upper, what's the mean that we're going to use for this problem?
Zero.
0, because it's a standard normal. So the mean is 0. What's the deviation?
1.
1. So we put in 1 for the standard deviation. We hit enter a couple times. And what do we get?
Point 0.685. Well, 3.8, but you rounded to 4.
Yeah, you round. But essentially what we get is exactly the same solution. So the calculated TI, the tables will be approximately the same, not exactly the same. And the online calculator, everything tells us the same answer, 0.6584. To review, for not for normal, for the standard normal distributions, it's 0 and 1. If it's not standard normal, then no, it'll have its own mean and it'll have its own sigma, and they're going to be different. But for the standard normal, it's 0 and 1. You'll have to be told that it's a standard normal. Otherwise, if you don't know it, you don't know which one to use. Does that make sense? Yes, no, maybe so? Anyone? Yes, thank you, okay. Okay, so 0.6584. So let's look at the next slide. This is slide number 19 now. And it says, question, who qualifies for college sports? It says the combined scores of the almost 1.7 million high school seniors taking the SAT in 2013 were approximately normal. The fact that it's approximately normal means we can use the normal distribution. With mean 1,011 and standard deviation 216. So quick, before we go on, are we talking here about the standard normal distribution or just about a normal distribution? And why?
What's the normal one?
Why is it not the standard normal one? What gives it that it's not the standard normal one?
It doesn't say standard normal.
That's not the reason. I mean, it's true. It doesn't say it, but maybe it really is. It It didn't say it, and we'd have to figure it out. But no,
It's got it.
Oh, the mean isn't 0.
The mean isn't 0, and the deviation is not 1. Right? What is the mean here?
The mean is 1011.
Well, that ain't 0 the last time I checked, right? Correct? Yes? Yeah, so if the mean ain't 0 and the deviation ain't 1, it ain't the standard normal distribution. Does that make sense?
Yes.
Okay. April, make sense? April? Because you said you didn't know. Okay, good.
Yeah, I get it now. Thank you.
Okay, so so now we have, it says the combined, okay, so what percent of high school seniors meet this SAT requirements of a combined score of 820 or better? So the first thing is we want to be 820 or better. So I'm going to share screen again. And let's go back to our normal distribution. So first, what is the mean of this normal distribution?
1011.
How much?
1011.
1011. So I go to the mean here and I put in 1011. What is the standard deviation?
216.
So I go here and I put in 216. Do we want an above, a below, or a between or outside situation for this problem?
Above.
Above, right? 820 or better. So it's going to be above, and it's going to be above 820. And you'll notice I don't even have to hit calculate because it just automatically does it. It gives me an answer of what?
0.8117.
0.8117, which is very close to what they got via probably an approximation. They got 0.8127, but I got 8117. So either the algorithm is a little off or someone made a mistake, but either way, it's fairly close. Does that make sense?
It does.
Yeah, okay, good. So let's look at this slide here. They just kind of do it pictorially as well, even though we have the answer mathematically. They said you want to the right of 820, that's the one on the left, right? You want to the right of 820, take the whole thing and subtract to the left of 820. The whole thing is 1, and to the left of 820 is 0.1873. How do I know that? Why do they even do this? Because they didn't have access to this website. This website's very great, right? Very powerful. It can go left or right, but most tables can only go left, or, I mean, a table picks one or the other. Most tables only go left. So if you have access only to a table and you want to the right, you got to do 1 minus to the left. But since in this class, you're always going to have access to this calculator, whether a TI-84 or an online calculator or whatever, then you don't have to worry about it. You can just do, do it in a calculator and get the answer. Okay, so let's look now. Let's scroll down a little bit, and let's go to slide number 21 now. Slide 21 says, SAT reading scores for a recent year are distributed according to N of 504, 111 distribution. So first, what does that mean, N of 504, 111? Did someone tell me in words what N of 504, 111 means? Well, so yes, Sydney, mean 504, standard deviation 111, but there's one other piece of information that you're leaving out. Well, correct, 100%. It's not the standard normal, that's right. But what is it? It's still normal, exactly. It's still normal, it's still a bell curve. It just ain't the standard normal, okay? But we don't care. We just wanna know what score you must get to score in the top 10%. Now, if I go back to my calculator, okay, so the mean is 504. The deviation is 111. And we want to be in the top 10%, right? So we want above some number to be 10%. Now, if I go above 820, That's not 10%. Let's go to 700 and recalculate. That's only 4%. Let's go to 650. Ooh, 9.42%. Let's go to 645. Ooh, a little too much. Let's go to 644. Still too much. Let's go to 642. Still too much. I thought 640 was too low. Oh, I'm going the wrong way. Whoops. Let's go 635. Whatever. Isn't this a kind of tedious way of doing it? Isn't it really tedious to try to guess that way? So there must be a better way of doing it. So here's how we're going to do it. Let's see if this calculator does it the right way. We want, notice how this calculator, you have to put in your numbers and the calculator will compute the probability, correct? But we want to start with the probability and then compute the numbers. So we want to go in the opposite direction. Does this calculator do that? So let's go here to the inverse normal. Here we go, the inverse normal. We want an area of how much? We want a shading of how much? Anyone?
10%.
10%. We want the top 10%. So we're going to put in for the area 0.10 with a mean of 504 and a standard deviation of 111, correct? Yes, no, maybe so? And then we say we want it to be above, and it gives us 646.252. And their answer was, look at that, 646.252. So now we know how to work backwards, right? We know how to start with the probability and compute the numbers, as well as start with the numbers and compute the probability.
Where's the inverse calculator again?
You're talking about on the website that I just went to?
Yeah.
It looks like it's, well, let's go back one. So when I did the Google search, it took me to normal distribution standard. But I want inverse normal distribution standard. So it's a little higher on the list. Do you see it?
Yeah.
So the normal standard takes us from numbers to probability. But sometimes you're given probability and you want to go to numbers. And in that situation, rather than using the regular normal, we use the standard normal, the inverse normal, and we go backwards. Now, how do I do that on a TI-84 calculator? I'm glad you asked. So let's do it now on a TI-84 calculator. Again, if you don't have a TI-84 calculator, not the end of the world. I do recommend getting one just because life is so much better with it. That's just my personal opinion, but you know, I don't go anywhere with that. So I'm going to stop sharing here so you can see better. I'm going to spotlight. There you go. So TI-84, starting in the same place. We're going to go second and distribution. Now you tell me what on this list we're going to pick to go backwards from probability to numbers as opposed to numbers to probability. Which one of these do you think is the correct one?
The third one.
The third one, inverse normal. And you'll notice that for the inverse normal, it looks very, very similar to what we had on the website. Does it not? You put in the area. You get to decide whether you want that area to be to the left, to the center, or to the right. That's your choice. So let's put it in. We'll put an area of 0.10. That's my area. What's the mean that we're going to use for this example? Anyone?
504.
504. We put in 504 for the mean. What deviation do we use for this example?
111.
111. And then we get to decide. What do we get to decide? Do we want to go left, medium, or right? So are we going to go to the right of, do we want the right to be 10%? Do we want the left to be 10%? Or do we want the middle to be 10%?
Is it the right?
It is the right. So we move it to the right because it's the top 10%. And what do we get as our answer? What do you notice there?
Same answer.
Hey, it's the same answer. Yes, to the right. I'm sorry, I didn't see it. I was holding up the screen, the calculator. So it is to the right, and it's the same answer. So all these techniques agree. They all give the same answer. It's a wonderful world that we live in because we have calculators to do our work for us. And one day these calculators will take over the world, and we're all going to die. But until then, things are wonderful. So are there any questions on what we did so far?
How do you use the TI-84 if you don't have the left, center, or right?
If you don't have left, center, right, and not everyone does, or you have to change the settings, I believe it automatically does to the left. I believe it automatically does to the left, which means when you get your, so which means instead of using 10%, because it's 10% to the right, what number would I put in if I want to the left? Right, I want that same point, right? I want, right, my goal here is to find the point such that there's 10% to the right of it. Well, if there's 10% to the right of that point, how much is to the left of that point?
90%.
90%. So I believe that the calculators that don't have the option of left, center, right automatically have left. So you're going to want to put in 90% for that situation because you and I are solving for the same point, but the details are a little different. Does that make sense? Yes, no, maybe, okay, okay. Oh yeah. Okay, so let's look now, please, on slide number 23. Okay, so slide number 23. It says the figure displays 3 density curves, each with 3 points marked on it. ABC, ABC, ABC. And the question is, at which of these points on each curve do the mean and the median fall? At which points do the mean and the median fall? So let's look at the first one. Which of these points is the mean and which of these points is the median? Let's send me the answers. 1, 2, 3, go. Oh, I say go again. All right, everyone in meeting, so go. All right, go for it. A, B, C. C is mean, A median. Okay, that's someone saying. The other person just says C is mean. Okay, what else we got? What other options we have here? Someone says A is median, B is mean. What other options we got? If you don't know, you don't know, that's totally fine. But if you do know, or you think you know, then say something. Only 2 people, 3 answered so far. There's like 40 people here. Where's the rest of you? Come on, let's go. You guys got this. I believe in you. Oh, a lot of I don't knows, or an O don't know. I'm not sure what O don't know means. But a lot of I don't knows.
Professor, are we talking about the first graph?
Yes, we are. I'm gonna say C. I don't know why, because I asked you for 2 different things: the median and the mean. So I don't know which one is C. C median, A, C mean, A median, mean. What does mean mean? Or are you the one who just said C? Complete sentences, my man. Complete sentences. Okay, so let's answer the following question. Ooh, someone sent a private message with the answer. That's how nice. Sir, yes, sir. That's right. Now drop and give me 20. 20 math problems it is. Okay, so is the distribution on the left symmetric, left skewed, or right skewed? Let's start there. Is the distribution symmetric, left skewed, or right skewed? It is a right skewed distribution. Do we all agree on that? Okay, so because it's right skewed, that means what is pulled more to the right, the mean or the median? The mean. The mean is pulled more to the mean. Wow, that's rough. But the mean is pulled more to the right. So anyone who said that A is the mean, you're straight up incorrect, because that would imply that you are back at the center, which is only valid if it's symmetric. But because it's pulled to the right, the mean has to be somewhat to the right. In fact, the mean and median are going to be to the right, because even though the median is not pulled as much, it's still pulled a little bit, which means C is the mean and B would be the median. C is the mean and B is median, which some people, now someone even said A is the mode, which is fantastic. A is the mode, that's true. We're on slide 23. Okay. So now let's go to the second one. And the question again is, and let's throw in the mode because someone mentioned it anyways. So the question is mean, median, mode. Write out what you believe the mean is, what you believe the median is, and what you believe the mode is. And let's then go ahead and check your answers. Fun times for everyone. So one person said mean. I don't know what that means. We're asking for a number of things here. Where is the mean? Where is the median? Where is the mode? We're asking for a number of things here. Sorry, accidents. I believe you. So we have a few answers here. So wonderful. So B is both the median and the mean, because it is a symmetric graph, which means the median and the mean are right on top of each other in the middle. And A and C are the mode. Very good. A lot of good answers here. What does that mean when there's two different modes? Do you need help?
No, I'm just really tired, just like in the brain,
But
not in the body.
But if you want me to bring it downstairs, just,
No. My body's fine. Just my brain is tired.
my brain's also tired. I want to take a nap also.
Am I just talking about naps in front of your whole class?
You are actually, yes.
Oh, take naps, everybody. Free student groups, sign petitions for schools. Take naps. Nap sign at all schools, all of LA County.
Okay. Wow. Welcome back. So, amen, huh? Okay, so, so A and C are both the mode. What do we call a graph that has two different modes? Anyone know what it's called? That's it. That's it. Nap time. That's it. Huh? What do we call a graph with two different modes? Someone just said it, I heard.
Unimodal?
So one more time. Bimodal. Bimodal. If it has one mode, it's unimodal. If it's two modes, it's bimodal. We don't really talk about three or more modes. So it's either unimodal, bimodal, or it just has no mode. So let's now go to the last one. Hopefully, after understanding the first one, we will all have no problems with understanding the last one. But the question here is, what is the mean, median, and mode for the last graph? And I just finished this here quickly. Okay, so let's see what we have here. Oh, only a few answers. Come on, let's get some more answers, everyone. Some more answers, please. I would love some more answers. Okay, so let's see what we have. So mean, B, median, C, mode. and various different variations, and that's all wonderful and correct. It looks like everyone was correct. The mean, it's a left skew distribution, so the mean is pulled to the left. The mean is pulled to the left. The mode is pulled a little bit left to the left, not as much as the mean. And the mode, sorry, the median and the mode is right in the middle. We are still on slide 23. That has not changed. And in fact, this is the end of this chapter. You'll notice that there's lots of slides after this. All those slides are lots and lots and lots of examples. All those slides are lots and lots and lots of examples. So let's do some of those examples. Let's do one from each slide. So let's do 3.8. This is slide number 24. 3.8. SAT versus ACT. It says in 2015, when she was a high school senior, and by the way, you can use your TI-84 for this, you can use a table for this, you can use your calculator, you can use the online calculator that I showed you. Use whatever you want, just get me the answer. So for all of these questions. So Linda scored 680 on the math part of the SAT. It was normal with a mean of 511 and a deviation of 120. Jack took the ACT, and that had a mean 20.8 and a deviation of 20 points. Mean 20.8 and Stan and scored 26 in the portion dirt. I think there was a typing problem there, and I believe what they meant to say is the mean is 20.8, the deviation is 5.4, and he scored a 26. So, are you laughing at me or are you laughing at the slide? I don't know. I'll assume it's a slide. Oh, okay, that's fine. So the question is, who scored better? Who scored better based upon the data? So how do we compare data that came from two completely different distributions? How do we do that? How do we compare data from two different distributions? What do we do?
Find their z-score.
Find the z-scores, yes. So let's find their z-scores. We don't need a special online calculator for that because we have a nice formula, don't we? How do we calculate z-scores? What do we do? What do we do? Come on, you guys know how to do this. What do we do? Well, yeah, standardize it. That's fantastic. So how do you do that? How do you calculate a z-score? How do you calculate a z-score? What 3x minus the mean, x minus mu over sigma. So let's do it for her, Linda. What is her x? What is her x? 680.
680.
And what is her mean? What is her mean? 120, 511. And what is her standard deviation? 120. So what is her z-score? Or his, yeah, her z-score. What is her z-score? I just calculated on my calculator, 1.41, right? Rounded to 2 decimals. We all agree, 1.41? I hope so. Now, let's do Jack. What is his data? What is Jack's data? He got a what? He got a yes, yes, yes. Oh, understand. Okay. What was his data? What was Jack's data? No, his data wasn't a 0.96. That wasn't his data. That's not what he actually got. Well, that could be. I don't know. I haven't gotten that far. You're too smart. Okay, 26. That's his data. I got to go slow. 26. And what was the mean for his distribution? 20.8. And what was the deviation for his distribution? 5.4. So if you calculate his z-score, you do in fact get 0.96. I just did it. So make sure that you get the same thing. And therefore, who scored better, Linda or Jack? Linda, yes, she kicked his ass. That's what she did. Wasn't even close. Jack should just give up now. That's what I say. All right, so let's go to slide number 26. We can go through all four of these. They're pretty quick. They're multiple choice. Let's do 3.15. It says, which of these variables is most likely, actually 315 is kind of tough, but let's try it. Which of these variables is most likely to have a normal distribution? Income per person for 150 different counties, sale prices of 200 homes in Santa Barbara, California, or lengths of 100 newborns in Connecticut. Okay, which one of those do we think will have a normal? Remember what normal is for. It's for natural occurrences where most are around the middle, and as it's very small or very large, the likelihood tapers off. So which of those three would be most likely to be a normal distribution? So I see some B's and some C's. Not a lot of answers though. Where's everyone else? Come on, everyone else. Come along for the ride. So lots of C's, good. Well, someone said B and C. I don't know. C's for sure. Newborn lengths is certainly a natural occurrence where you're not going to have very many big or small babies, but most of them are around the middle. Sale prices for 200 homes in Santa Barbara, California. I don't really know Santa Barbara, California very well, but is it an affluent location? No, yeah, Sydney, you've seen some big babies, man, right? I know, and I'm sure you've seen some preemies as well, but the majority of them are certainly going to be around average, right? You're going to have some big ones and some small ones, but the majority of them are going to be in the middle. Would you agree? I hope you agree. You're not saying I agree or yes or acknowledging my existence, but I hope you agree with that. I guess it depends on the specific location. Yeah, I mean, B is tough, right? B is tough. For what, the big babies part? I mean, in a million babies, you're going to have most of them be right around average, and you're going to have some big ones, and you're going to have some small ones, but on the average, it's going to be normal because it's a natural occurrence, and most occurrences are normal. I hope that made sense. Anyways, number 3.16. To completely specify the shape of a normal, you must give A, the mean and standard deviation, B, the 5-number summary, or C, the median and the quartiles. A, B, or C, mean and deviation, 5-number summary, or the median and the quartiles. Which is correct for a normal distribution? Right across the board, boom, all the A's. Not even easy. That's not even a hard one. Okay, good. 3.17. The figure shows a normal curve. What is the mean of this distribution? A, B, or C? 0, 2, or 3? A, B, or C? What does it mean of this distribution? A, B, or C? Again, it's an easy one. Bam, right in the middle. I guess you might need to verify that 2 really is a center and not 3, but it does look like it's 2, so the answer is B. What is the standard deviation for this one? A, B, or C? 2, 3, or 5? Now for this one, don't just say what you think, but actually justify it. Assuming it's one of those 3 answers, eliminate 2 of them, and then give me the third. Two spaces from the mean? What do you mean 2 spaces from the mean? What does that mean? I don't know what that means. I'm sorry. What does that mean? Where'd my wallet go? So let me show you how I would do this one. Okay, so we're doing this one here, right? Correct? So I'm going to go ahead and I'm going to annotate. And when I annotate, I say, okay, the mean is 2. So there's 2 right in the center. If I go 5 from 2, I get to 7, which is right there. Does that look like the point where the graph switches from being a hill to a bowl? Or does the bowl go further? It looks like the bowl goes further. If I do 2 from 2, which is 4, then I'm claiming that this is the point where it switches from being like a hill to like a bowl. But it looks like the hill goes further. But if I do 3, which gets me to 5, that's horrible. Then that seems a more realistic location where it switches from being like a bowl to being like a hill. And therefore the answer should be 3. Did that make sense? Hope it made sense, because we certainly talked about that idea. And the rest of them, let's do some more here. We did those. Okay, let's do 3.19. 3.19 is very straightforward. Let's try 3.19. Go ahead, please, and do 3.19. I'd like you to think about 3.19 and then tell me what the answer is. Okay. What's the answer to 3.19? So don't just guess A, B, or C, because you can certainly guess, but I would like you to justify your answer with logic. So whatever you get as the answer, make sure it's logical. So if you say an answer, I might call on you and say, well, why is it that answer? Shocking how I can do that. So I only have 2 answers so far. I'm hoping for more, hoping for more. Oh, look at that. C, because of the 68, 95, 99 rule. Technically the 99.7 rule, but I know what you're trying to say. The inside 95% is how many deviations? It's 2 deviations, right? So if we have a mean of 6.5 and a deviation of 1 hour, then 2 deviations is how much? 2 deviations will be 2 hours. So if I go 2 hours to the left of 6.5 and 2 hours to the right of 6.5, where do I end up? Where do I end up? Anyone? Anyone else? Someone? If I go 2 deviations left and then 2 deviations right, where do I end up? 4.5 and 8.5, which is why the answer is C. Okay. Now, let's do 3.22, and you can use your online calculator for this. But let's go ahead and do 3.22. We're looking for the proportion of observations from a standard normal distribution that take values greater than 1.78. Can we do that either on the TI-84 calculator, the online calculator that I found, or straight up, if you want to use a table, you can go ahead and use that too. So please go ahead and do this. Please explain again. Okay, so not to explain, it's just a question, right? The question is question number 3.22. We're looking for the proportion of observations from a standard normal what website did I use? I just did a Google search. My Google search was normal distribution calculator. That was my Google search. Normal distribution for 3.19. Oh, well, it's a night. Okay, what is the 68, 90, 95, 99.7 rule say? What is that rule? Can you tell me what that rule is? What is the 68, 95, 99.7 rule? What does it say?
68 falls within you.
I'm sorry, I can't hear you.
Oh, the 68% of it falls within the mean, and then 95%.
Wait. Falls within the what?
Oh, hold on. The deviation of the mean.
One deviation of the mean. Good.
And then 95% is 2 deviations from the mean.
Good.
99.7% is 3 deviations from the mean.
Okay, and we want to be how many deviations from the mean? Sorry, let me rephrase that. We want what percent?
95%.
We want 95%, correct? So how many deviations from the mean are we going to go to get 95%?
Okay, I got it. Thank you.
No, someone else might not have it. So answer the question. How many? How many?
2.
2. And now in this problem, a deviation is what percent? Or sorry, deviation is how many hours?
1 hour.
So 2 deviations is how many hours?
2.
Okay, so if my mean is 6.5, and I can go 2 hours this way or 2 hours that way, then it's going to be from what to what?
4.5 to 8.5.
4.5 to 8.5. Does that make sense?
Yeah, thank you.
Okay. So we're back to number 3.22. I'm still waiting for an answer. We're looking for the proportion of observations from a standard normal distribution that take values greater than 1.78. Still waiting for someone to say A, B, or C with a reason. Would love if someone can get this, please. That would be just amazing. So let's see what we have. Someone has C. So someone asks for a TI-84 calculator, do we use normal CDF or inverse norm? Well, let me ask you a question. What are we looking for here? Are we looking for a probability or are we looking for a value?
A value?
We're looking for, well, what does it say?
A proportion?
A proportion. So we're looking for a probability or a proportion. Normal CDF gets me from a number to a proportion. Inverse gets me from a proportion to a number. So in this case, we're going to a proportion, we're going to use a regular normal CDF. Or, of course, we can always use the calculator, the online calculator. Does that make sense?
Wait, I'm a little confused. Can you say it one more time? Sorry.
Sure. If you're going from a proportion, if you're going from numbers to proportions, we use the normal CDF.
Okay.
If you're going from proportions to numbers, that's when we use the inverse.
Okay, so since we're going from we're going from numbers from 1.8, and they were trying to find a proportion. So we're going to use normal CDF?
That's correct.
Okay, thank you.
That's correct. Okay. So I have 2 answers so far. I have a C and an A. I'm still waiting for at least a bunch of other people. I got 1 from the calculator. We got 1. It gave you literally the number 1. Or approximately 1. It gave you exactly 1. I think you put it in, I think you put something in wrong. Because that doesn't make sense. Unfortunately. Waiting for the rest of you. Come on, we just did this a few minutes ago. Talk to me. What are we all doing? So I typed in mean 6.5. Where do you get a mean? No. 3.22 is nothing to do with 3.19. This is a completely different problem. It's okay. 3.22 is its own problem.
I have a question.
Yeah.
So I'm using the calculator, but I'm confused like what number we put for lower.
Well, you want to take values greater than 1.78, correct?
Yes.
So from what number to what number? Greater than 1.78 is from where to where?
Based off what? Like,
Yeah, 1.78 to infinity.
oh,
So what's the lower going to be? What's the lower going to be?
wouldn't it be anything below 1.78?
No, we don't want both below 1.78. We want to go 1.78 and above. We want 1.78 to infinity. So the lower is 1.78.
Oh.
That's our starting point. What's our stopping point? How high are we going to go?
Infinity?
Well, your calculator you can't put in an infinity symbol and have your calculator understand that. So what do you put in instead of infinity? What can you put in instead of infinity?
Isn't it 999?
Yeah, I just put in a lot of nines, right?
Okay.
9999999. That's a really big number. Okay, so lower is 1.78. So I'm going to go to my second distribution, normal CDF. 1.78, upper 9999999, standard normal, so mu is 0, sigma is 1. I hit enter. What do I get? What do I get?
0.0375.
0.0375.
Okay.
So A, B, or C, which one is it?
C.
So the answer is C. Let's do 3.23 while we're at it.
Thank you.
You're welcome. Could we do 3.23? Can everyone please do 3.23? Same way. Can you show how to do it? I just thought okay. Oh, on the online calculator. Go to that website. Are you still there? The normal distribution calculator website? Yeah? Okay. And we're going to put in, what's the mean that we're going to use for this problem? The mean is not 1.78. The mean is not 1. What kind of distribution is this? The mean is 0. This is a standard normal distribution. The mean is 0. Yes? What she's asking to do the same problem that we just did, but on the online calculator. So when I go to my online calculator, mean 0, deviation 1, above 1.78, calculate, and it gives me 0.0375. Does that make sense? Okay, so do 3.23, please. 3.23, the next, I think it was 3.23, yeah. The proportion of observations from a standard normal that take values between 1 and 2. And you can either do this in your head, knowing the 68, 95, 99.7 rule, or you can do it rigorously if you don't, or you're not sure how to do it. So, oops. No, what did I just do? Oh, I don't spell. Okay. So we got a lot of answers B, and B is correct, 0.135. Who did it on a calculator and who did it without a calculator? I'm just curious. Calculator, 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 because I'm lazy. I love it. Calculator, 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 calculator. Right? Lots of calculators, which is totally fine. But someone walk me through how I could have done it without a calculator. Two deviations from the mean, what percent? 95. One deviation from the mean, what percent? 86. 68. So between 1 and 2 is what percent? $95, 68. What's in between? Not exactly 25, be a little more percent, 27. Half here, half here. What's here? $13.5, which is B. So it could have been done to without a calculator, and nothing wrong with doing it with a calculator, 100%. But sometimes we like to have a way of doing it without a calculator, which is a little quicker. Okay. Anywho, so this is the end of the third chapter. I will put up the Launchpad homework tonight so that you have, you can do it. And then next time we'll start chapter 4. So any questions on what we did today? No questions. So just out of curiosity, since we have 4, 8, 12, 16, 20, 24, 28, 32, 30, I have 39 people watching me right now. Do a little test to see who's actually here. I would like everyone to type in the word here right now. If you did not type in the word here, and I'm giving you 5 more seconds to do it, then I will mark you as absent. "39 here's." Perfect. Wonderful. The test was success or a failure, depending on your viewpoint. But that'll be it for today. It's about 8 o'clock, and I didn't give you a 10-minute break, so I guess I'll give you the 10-minute break at the end. Go over the stuff, please, please, please. The homework will be up tonight. You'll have a week to do it, and I will see you all on Thursday for more fun and excitement. You're welcome, Grace. I will see you all later. Have a great night, everyone.
Professor, you said chapter 1 and 2 homework is also due next week?
I extended chapter 1 and 2 for another week. I will tell you, Sydney, I'll tell you in a second. Hold on. Thank you, guys. I extended it another week, and the third one will also be due a week from today. So all 3 will be due a week from today.
Got it. Thank you.
Okay. So Sydney, again, 2 deviations out in either direction is what percent of the data? Oh, yeah. So from 27. 27% is in these 2 parts together. But if I only want one of those 2 parts, I just divide it by 2. Right? It's half, right?
Oh.
So 27% between 1 and 2, but half of it on this side and half of it on this side. So 13.5%. Approximately. Not exact, but it's pretty close. Make sense? You're welcome. Okay.
Professor Berkowitz,
Yes, sir.
So the question 3.20, were we supposed to use the calculator for that?
Let me take a
Because there
look.
was no obvious way to do that without a calculator.
Hold on. Let me take a look at. Let me look at 3.20 again. I'm gonna load it up.
Yeah. The percentage of college students that sleep at night at least 8 hours per night is about blank.
Just give me 1 second. I'm sorry. I'd rather see it if that's okay. But where am I? Oh, here we go.
Oh, it's slide 29.
Okay,
Or
slide
28.
29. So 3 point. Which one are you looking at?
3.20.
Oh, at least 8 hours.
Yeah, because for some reason I had this idea that I wasn't supposed to do it with a calculator.
No, that is certainly a table or a calculator problem.
Right, because the standard deviation was 1.5, and so I couldn't easily apply
That's exactly.
the 68, 95, 99.7 rule.
That's exactly it. The 68, 95, 99.7 rule only holds for 1, 2, and 3.
Yeah.
Any other number, you got to use a calculator or a table or some kind of program or something.
Right. That all makes sense. So we really need to work on this and like understand these little rules of thumb, like, you know, the standard deviation being the inflection point and these percentage rules and stuff to be able to to break down some of these work problems.
Yeah. I mean, listen, I can only do so much in class. I can't do every single problem. I can't cover every little detail.
It's fine.
So what I do is I give you the foundation, and I try to give the foundation, and then you got to go and do the homework. And I pick the homework questions. They're designed to make sure that you understand all those nuances. Sometimes they'll ask questions, and it's like, how do I do this? And that's when the real learning comes in. When you go from I'm not sure how to do this to, oh, I get it now. And you really see which part you knew and which part you didn't know.
Absolutely.
Right.
I know I confused you last time with my trigonometry comparison to comparing stats to trigonometry. But you know what? I just see it more and more that the standard normal graph is kind of like how we use the unit circle as the most broken down, simplified possible way we can express a shape.
In that sense, in the sense of, you know, you use this to get other things.
Yeah.
Then yes, certainly. I mean, but you know, you could say addition is the cornerstone of of multiplication, and I mean, you can always make that analogy as one thing is needed for other things.
Yeah.
I thought you were looking more in depth as to some of the applications of trigonometry. And Sydney, the answer is no. Oh, wait, Sydney, give me a second. I thought you were looking at something a little more in depth than just you need this to do this type analogy.
Well, it was definitely focusing on simplifying the entire equation of a shape in order to focus on just the common variables, because you can always make the angle down to having a radian of 1, and you can always take these graphs down to having a mean of 0 and a standard deviation of 1, and that's kind of where I saw the similarity. Anyway, that's not very important. That's just me talking.
Okay.
Have a great night.
You too. I'll see you on Thursday.
See you on Thursday.
And Sydney, the question was, how do we do 3.20 on the calculator? Well, first of all, 3.20, what type of normal distribution are we dealing with? Is it just a normal, or is it the standard normal?
It didn't say standard, so I just assumed it was normal.
Okay, well, if it doesn't say it, and it doesn't give you any indication, then yes, it's just normal. But we need to know the mean and the standard deviation. Do they give it to us?
They gave us at least 8 hours.
Right, but 3.20 seems to be a continuation of 3.19.
Oh, okay.
Because it's talking still about college students, and the previous question was dealing with college students, right?
Oh, okay.
Plus it starts with the word also.
Okay.
Right.
Okay.
Well, that word also seems to indicate that there's a connection between them.
Okay.
Does that make sense?
So the mean would just be 6.5 for the standard deviation of 1 hour, and I just have to do below 8.
I thought we want more than 8 hours. Do we want more than 8 or do we want less than 8?
They say at least 8 hours.
At least 8 means 8 or more.
Oh, okay. So above 8.
Above 8.
Okay. Okay. Thank you.
Does that make sense?
Yes. Thank you.
You're welcome.
Professor, are you gonna post this lecture? Because for like a few 20 minutes I couldn't connect. My internet was like really bad, so I missed a little bit.
So as soon as I close this a meeting, it will automatically upload the things to my computer, and then I will post them immediately.
All right.
Okay. It takes like a half an hour, but because it's the whole day. But yeah. Okay.
Okay.
No problem.
Thank you.
Welcome.
Have a good night.
You too. I'll see you on Thursday.
Thank you.
Hey, Professor. I emailed you over the weekend because I'm still having problems with Launchpad. I took a look at it again today, and I think I'm basically just in a different professor's class. But when I tried to search up just under your name to find the course on Launchpad, I couldn't find it.
Did I send to you the invitation to my Launchpad class?
You know what? I don't think I ever got that.
When did you join the class?
I enrolled over the summer.
Well, you've been here for the whole time.
Yeah.
Then you should certainly have received the invitation from me.
Maybe I overlooked it somehow. I just typed in the access code on Launchpad.
Yeah.
And searched it. I just couldn't find your class, but maybe that's what it was.
So let me load up Launchpad again and see if I can find on here the invitation. Hold on.
Thank you.
Course info maybe? No. Where is it? Where is it? Let me look for it. You said you sent me an email? Maya?
Yeah, I emailed you.
Okay, let me look for it, and then as soon as I find it, I will email it back, and you should look for it as well, because I don't know. I mean, I should be able to find it pretty easily, right? It doesn't seem to appear anywhere. So I will look for it, and I will get it to you as soon as I find it. How's that?
Okay, that sounds good. Thank you.
That's the best I can do. Okay.
Okay, thank you.
Okay, I'll see you on Thursday.
Okay, bye.
Okay, bye. And then there were 5. Who else has a question? Okay, well, I'm going to stop recording. Are you guys here? Katrina Marshall, you said here, so you were here. Nobody's responding. What does that mean? Well, I'm leaving. Okay, bye, guys.